Okay, you sometimes need to compare dynamic and static data structures against each other. So let's go through some key facts. So static data structures are inefficient because memory is allocated that may not be needed. So you could be allocated, I want a static data structure of 100 memory locations and you might only use one. So that is inefficient, or it can be inefficient. It depends on its use. If you're storing the top 10 leaderboard of a game and it's always got 10 names in, that might be efficient. But generally speaking, most of the time it's inefficient. The advantages of it, though, is it's fast to access the data as the memory location is fixed when the program is written. Okay, so it's faster than dynamic to access the data because, especially like we mentioned, they're often sequential, which is the point underneath. Look, memory locations allocated are also sequential, which increases access speed. So you're not needing to use pointers to bounce around to different memory locations. So it's much faster to access the data. Structures are a fixed size, which may then make them a bit easier to work with, a bit more predictable. The relationship between different bits of data does not change. So what we mean by that is, like the second position is always the second position in the structure. Okay, so the relationship and the location, memory locations, again making them slightly easier to work with, and they never change. And it only uses a couple of pointers, so it uses it uses less memory for large structures or if all locations are used. Okay, so typically, in the same way, it's not always inefficient, but most of the time, except for a couple of examples, it's way more efficient on memory. Okay, we're more efficient on memory in terms of the pointers. So if all your locations are used, if you are using them because of the points as well, or if you've got, I don't know, I've got a dynamic that's containing 5 memory locations, I've got a static that's containing 5 memory locations. The dynamic needs more pointers as additional memory than the static does. So in that case, the static would be a better implementation. But then again, if I've got 10 items where only 5 are used in dynamic, I'd only be using 5. So therefore that would be better. It's confusing. But anyway, dynamic, it's all dependent on what you're using for, which one's better. They both exist for a reason. Efficient, dynamic are typically efficient as the amount of memory varies as needed. However, it's slower to access each element as the memory location is allocated at runtime, and you've got to use the pointers to hop between during access the memory locations. Memory addresses are usually fragmented, which reduces access speed. So think of, like, let's say they're stored on a magnetic hard drive, they could be on different platters, or they won't be typically, they'll be in RAM. Sorry, if they're in RAM, they could be in different sections of RAM, which again reduces access speed when compared to if they're in sequential locations. They vary in size, and because of that, you have to calculate the length. If you're a static data structure, the length is defined, so you know it. Because these vary, you have to actually navigate through the structure to find the length. The relationship between different elements of data will change as the program is run. Because again, the memory locations won't necessarily mean you're in position 1 or position 2. It's the pointers that define the relationship between the elements. And finally, it uses a lot more pointers than static, so it can be inefficient in some cases. All right, so static and dynamic are different ways of storing data. It depends on its use, which one is better. And it's I'd say have a look at the exam questions to see how these come up. But these things here are the answers to everything we've seen so far in terms of exam questions when comparing static and dynamic data structures.